Hello and welcome back to my YouTube channel, Physics by Garima. I hope you found my previous video in which I have discussed 20 questions on CSA Physics exam that is conducted on 25 April. Now in this video we are going to discuss 20 questions. Let's start with the question number 21. A spring mass system takes 0.5 seconds to complete one oscillation. The frequency of oscillation is. Here time period is given as zero point 0.5 second and we know that frequency is equal to 1 by time period. We will put the value of time that is given as 0.5. So when we solve this it will become 2 hertz. So option D is correct. Question number 22. A sound wave has a frequency of 400 Hz and a speed of 340 meter per second. Its wavelength is. We know that frequency is equal to velocity by wavelength. So wavelength will be is equal to velocity by frequency. We will put the value of velocity that is 340 divided the frequency which is given as 400 Hz. When we solve this it will become 0.85 meter. So option C is correct. Question number 23. Two identical metal sphere of charges plus 4 coulomb and minus 6 coulomb after they brought into contact then separated, the charge on each sphere is. This is the sphere 1 having charge plus 4 coulomb and this is the sphere 2 which is having a charge of minus 6 coulomb. These two spheres are identical and when these two spheres they are brought in contact then there will be redistribution of charges. So the charges will be distributed since these are the two identical spheres, so the charge distribution will be equal. So it will be divided by 2 which will become minus 2 by 2 that is minus 1 coulomb. So when these two charge spheres are separated both the spheres will have minus 1 coulomb of charge. So according to this option D is correct. Question number 24. An object has a mass of 11 kg and a weight is g is given as 10 meter per second. We know that weight of object is equal to mass times acceleration. Mass is given as 11 and g is given as 10. So it will become 110 Newton. So according to this option A is correct. Question number 25. The electric field are distributed as shown in figure. Points A and B are placed with equal positive charges. The relationship between electric field FA and FB. Here the two charges are placed at region at point A and B. At point A, if we see in this point the electric fields are far from each other. So electric field at point A, here the strength will be low as compared to the electric field at point B. Here the electric fields are more crowded, so strength at at B point will be more. So according to this, so force at point A will be less as compared to force at point B. So according to this option D is correct. Sorry, option C is correct. Now move to question number 26. Resistors of 100 ohm and 200 ohm, they are connected in parallel. The total resistance is. Here two resistance are given and these two resistance they are connected in parallel. First resistance is given as 100 ohm and second resistor is given as 200 ohm. And we know that the equivalent resistance in parallel Rp is equal to, that is 1 by Rp is equal to 1 by R1 plus 1 by R2. We will put the value of R1 that is 1 by 100 plus 1 by R2 and R2 is given as 200 and this will become 200 plus 300 divided by 200 plus 100 divided by 100 into 200. So Rp will be equal to 100 into 200 divided by 300. So when we solve this, it will become 200 by 3. So it will be equal to 66.7 ohm. So option D is correct. Question number 27. Two resistors of R1 6 ohm and R2 4 ohm, they are connected in parallel across 12-volt power supply. The ratio of current is. Here two resistors are given and these two resistors are connected in parallel with a power supply of 12 volt. So here R1 is given as 6 ohm and R2 is given as 4 ohm and power supply is 12 volt. So the current I1 is flowing through resistor R1 and I2 current flowing through resistors R2. So I1 will be equal to V by R1 since voltage in parallel remains same across both the resistors, and I2 will be equal to V by R2. Then for calculating I1 and I2, we will take the ratio. So I1 by I2 will be equal to V, we get cancelled, R2 by R1. R2 is given as 4 and R1 is given as 6. So it will become 2 by 3. So option B is correct. Question number 28. A point charge Q produces electric field E at point A. If the distance from the point charge to point A becomes twice its original value, the electric field strength becomes. Here, suppose this is the charge Q, which is producing electric field at point A. So, electric field at point A will be equal to kq by r square. Suppose the distance is r. Now, this point A is moved at a distance of 2r. Suppose this is point B and the electric field at point B will be equal to kq divided by 2r whole square. So when we solve this, it will become kq divided by 4r square, which is equal to 1 by 4 times the initial electric field, that is the electric field at point A. So according to this, option C is correct. Now move to question number 29. That is the SI unit of magnetic flux density and magnetic flux R. So option B, that is magnetic flux density, its unit is Tesla and magnetic flux unit is Weber. So option B is correct. Question number 30. Light travel from air into glass. If angle of incidence is 45 degree, the angle of reflection is. Here, suppose this is the interface and light is traveling from air to glass, so it will bend towards normal. This is the angle of incidence I and this is the angle of reflection R. So according to law of reflection, angle I is equal to angle R. Here angle of incidence is given as 45 degree. So angle of reflection will also becomes 45 degree. So according to this, option C is correct. Question number 31. As shown in figure, A and B are the 2 points on the ceiling fan. When fan rotates at constant speed, what is the correct relationship between linear velocity and angular velocity at points A and B? Here, since fan is moving with the same angular velocity, here it is rotating with a constant velocity. That means the angular velocity at both the points, that is omega A and omega B, will be equal, that is omega. And we know that linear velocity V is equal to R times omega. This is the velocity at point A and RA, this is RA. This distance is RA and this distance is RB. Since RB is greater than RA, that means, and velocity at B point is RB into omega. That means velocity at B point will be greater than velocity at A point. So according to this omega A will be equal to omega B and VB is greater than VA. So option C is correct. Question number 32. A wire of length zero point 0.5 meter is placed in a magnetic flux density B is equal to zero point 0.4 Tesla, experiences maximum magnetic force of zero point 0.2 Newton. The magnitude of current is. Here, the length of wire is given as zero point 0.5 meter. Magnetic flux density B is given as 0.4 Tesla. Magnetic force is 0.2 Newton. We know that the force experienced by a current carrying wire is equal to I into L into B sine theta. Since here the wire is experiencing the maximum force, so theta will becomes 90 degree. Now we have to calculate current. So I will be equal to force divided by L into B sine 90 is 1. We will put the value of force, that is 0.2, divided by L is 0.5 and B is 0.4. And when we solve this, so this will become 1 ampere. So according to this, option C is correct. Question number 33. A fixed amount of gas is kept at a constant volume. Its temperature increases from 27 degrees Celsius to 54 degrees Celsius. The pressure becomes times its original value is. Here, the volume is given as constant. So according to ideal gas equation, PV is equal to nRT. We can write P is equal to nR by V into T, and this term will become constant. So pressure will be proportional to temperature. So according to this, we can write the pressure P2 is proportional or equal to K into T2, and like this, P1 is equal to K times T1. We'll take the ratio, this get cancelled, and P2 by P1 is equal to T2 by T1. So T2 is the temperature which is given as 54 degrees Celsius. We need to convert that to be in Kelvin. So we will add 273 to this and 27 plus 273. So this will become 327 divided by 300, and when we solve this it will become 1.09. So option A is correct. Question number 34. A coil has a turn of 50. The magnetic flux through it increases uniformly from zero point 0.2 Weber to zero point 0.6 Weber in 0.1 second. The electromotive force is. Here, the number of turns N is given as 50, and suppose the initial flux phi1 or phi initial is 0.2, and final flux is given as 0.6 Weber, and time is given at 0.1 second. We know that EMF is equal to minus N into d phi by dt, or change in flux with respect to time. Then this will become N is given as 50, and change in flux will be final flux minus initial flux divided by time. So it will become minus 50 into 0.6 minus 0.2 divided by time, that is 0.1. So it will become 0.50 into 0.4 divided by 0.1. It will become minus 200 volt. So the magnitude of EMF will be 200 volt. So according to this, option A is correct. Question number 35. A small ball has a mass of 0.2 kg, falls freely from the height of 2 meter to a ground. The change in gravitational potential energy is. G is given as 10 meter per second. Suppose this is the ball which is falling from a height of 2 meter, and the ball is having a mass of 0.2 kg. Suppose this A here, this is the initial potential energy, and UF is the final potential energy. and we need to find the change in potential energy. Change in potential energy is equal to final potential energy minus initial potential energy. Here the height h is 0, so the potential energy final, that is mgh minus mgh, we can write this to be h2 and this to be h1. Since height h2 is 0, so here the potential energy will be 0, and mgh1, here h1 will be 2 meter, we will put this value, and this will become minus m is given as 0.2 and g is 10 and height is 2 meter, so it will become minus 4 joules. So according to this, option B is correct. Question number 36. The resistance of an electric motor is 2 ohm and the rated value voltage is 100 volt. When it is working normally, the current passes through it is 3 ampere. Therefore, the power loss caused by heating during the operation of electric motor is, here the total power supplied to electric motor is, this is the total power, that is V into I. Voltage is given as 100 and current is 3. This is the total voltage, or this is total power of 300 watt which is supplied to the electric motor, and out of which the power loss is I square into R, which is equal to, I is given as 3 ampere, that is 3 square, into R. Resistance is given as 2, so it will become 18 watt. So from 300 watt, 18 watt of power is lost by the electric motor, so option B is correct. Question number 37. When a light travels from optically denser medium to optically rarer medium, the angle of incidence is greater than the angle of critical angle. So this is the necessary condition for the total internal reflection, where the light travels from optically denser to optically rarer medium and the angle of incidence is greater than than the critical angle. So the phenomena that takes place in this is total internal reflection. So option A is correct. Question number 38. 2-point charges QA 2 into 10 raised to power minus 9 coulomb and QB minus 2 into 10 raised to power minus 9 coulomb in a vacuum are separated by a distance of 4 centimeter. The magnitude of electric field strength at the midpoint of the line joining connecting them is, here K is given as 9 into 10 raised to power 9 Newton meter square per coulomb square is the constant. So here two charges are given and both the charges are having the same magnitude. Suppose QA and QB both are given as equal, and I am taking that to be Q, which is given as 2 into 10 raised to power minus 9 coulomb, and these are separated by a distance of 4 centimeter. These two charges, this charge is QA and this is the charge QB, and we have to find the electric field at the midpoint, and these two charges, they are separated by a distance of 4 centimeter. So the electric field at midpoint by QA will be in this direction. This is electric field due to A point, and this is positive charge and this is negative charge. So electric field due to QB point, this will be in this direction. So the net electric field will be the sum of both the electric field, and so EA will be equal to KQ by distance square, where this will be the distance which is R, that is 2 centimeter, and EB will be equal to KQ by R into R square. Since the magnitude of both the electric field, since this implies that magnitude of electric field at A point is equal to magnitude of electric field at B point. So the magnetic field at the center, that is at O, the net electric field will be equal to EA plus EB, which will be equal to KQ by R square plus KQ by R square. It will become 2 KQ by R square. Now we will put the value that is 2 into k is given as 9 into 10 raised to power 9. Q is given as 2 into 10 raised to power minus 9, and distance is given as 2 centimeter. So this is the distance, and this distance is 2 centimeter. It will become 2 into 10 raised to power minus 2 meter whole square. When we solve this, so it will become, this will become 4 into 10 raised to power minus 4. So this 2 and this 2 get cancelled with 4, this 9 and this minus 9 get cancelled, and this minus 4 will go on the numerator, so its magnitude will come as 9 into 10 raised to power 4 Newton per meter. So according to this, option D is correct. Question number 39. For a particle undergoes simple harmonic motion, which of the following quantities has the maximum value when the particle is at the equilibrium position? Suppose these are the uh, these are the position at which the particle is doing the SHM, and O is the equilibrium position. This is the amplitude, this is the maximum distance, and we know that at the A and B point the particle will be at rest. Here the potential energy is maximum at this point. So, and the particle is stopped at this point, so kinetic energy is 0 here. But here, since the particle is at equilibrium, so here the velocity is maximum, or we can say that kinetic energy is maximum. So according to this, option C is correct, that is the velocity is maximum. Now move to our last question, that is question number 40, which says that as shown in a figure, an object of mass 5 kg initially at rest slides down a slope inclined at 30 degrees from B to A. The frictional force acting on the object during the descent is 5 Newton. Given that the distance from A to B is 2 meter, and we have to calculate the velocity of object at point A, and G is given as 10 meter per second square. So first we will draw all the forces that are acting on the mass M. So this is the normal reaction which is due to the ground, and this is the mg that is due to gravity. This is the force, and we will resolute this mg force. So its component will be mg cos 30 degree, and this will become mg sine 30 degree. Since object is moving in downward direction, so frictional force will be opposite to this is the frictional force, and we know that v square is equal to u square minus 2as. First we need to calculate the acceleration. So acceleration will be equal to, that is the net force divided by mass. So net force is, since object is moving in the downward direction, it will be mg sine 30 degree minus friction force divided by mass. So we will put the value of mass, which is given as 5, g is 10, sine 30 is half, minus friction force is given as 5 Newton divided by mass is 5. So this will become 25 minus 5, that is 20 divided by 5. So it will become 4 meter per second square. Now we will put the value of acceleration in equation number 1. V square minus initial velocity is given as 0 minus 2 into acceleration is 4. So it is moving in downward direction. Acceleration will be minus 4, and the distance it moves is given as 2 meters. So it will become 16 meter per second v square. So velocity will be 4 meter per second. So according to this, option A is correct. Thank you for watching. I hope you enjoy the video. Thank you.